Alright guys, today we're talking about magnitude, so you want to be in your note packet on the section of magnitude. It's the first section of note packet number 2. And you have basically 4 exercises we want to work through. We're talking about really big numbers or really small numbers. So let's just take a minute here and talk about some powers of 10. Alright, and last week or so we've been talking about exponents. So if I take 10 and I raise it to the 0 power, we said everything raised to the 0 power gives you a 1. Alright, and if I take 10 and raise it to the first power, well, I just get 10. And we're going to start to see a little pattern that emerges here. If I take 10 and raise it to the second power, I get 100. And if you haven't seen the pattern yet, we'll do another couple here. 10 raised to the third power, that is 1,000. That's 10 times 10 times 10. And 10 raised to the fourth, of course, is going to give me 10,000. That's 10 times 10 times 10 times 10. And if you haven't seen it, looks like every time we raise 10 to a power, if we look at the exponent, that's how many zeros I'm putting after the 1. Alright, you can see that there's 1 0 there, and 2 zeros there, etc. Okay, so that's a little trick to raise the powers of 10 very easily. Alright, and I'll put a few more down just for kicks and giggles. And what we want to know in exercises 1 and 2, we want to know what are the smallest power of 10 that will exceed, that number that you have in front of you. Now make sure everybody knows what the word exceed means. To exceed something is to be bigger than that. So I'm going to try number 1 over here. I want to exceed this number, but I want the smallest power of 10 that will be bigger or exceed this number. Alright, so let me try to put something that might work right here. Let's try to put a number right below it that's going to be a power of 10. And how about that number right there? Let's see, is this number exceeding, is this number in red, exceeding this number? Well, no, it's not, because these match up. We've got zeros that match up with all of these numbers except for this first 9 and this 1 match up. So this 9 is bigger. So this number that I have here is actually smaller. Alright, I need one more 0 to make this number bigger. I'm going to switch colors here, and I'm going to write what I want to get. I need one more 0, so that's going to put this 1 over 1. And I'm going to have, this is the number I want to get to be a number that is bigger than the number in blue up there, or exceeds. Okay, so this one is bigger. Alright, so now the question is, what power of 10 is going to do that for me? What is this number? This number right here. What is that number in the power of 10? Well, if I go over here to my little pattern, and I say to myself, well, I need this many zeros, and I look at my pattern, and whenever I needed 3 zeros, I raised 10 to the third, and whenever I need 4 zeros, I raised 10 to the fourth. So if I just count the number of zeros over here that I need, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I need 15 zeros to make a number that exceeds this one. So it's simply 10 to the 15th. Alright, so if you see this pattern, if you know this fact, it makes that problem really easy. Okay, so let's try number 2 down here. Now this is a really funny fraction over here. Who would ever use the fraction 750 over 988? And I put that on there specifically because I want you to see that you can do this very easily, pretty much with any fraction. It doesn't matter. It can be 3/4. It can be this wacky fraction that we have here. What would 750 divided by 988 actually be? Look at that decimal. That's why I put it as a fraction, because it's an irrational number. It's just going to go on forever. There's no repetition. All right? So approximately, if I were to round this, that little 5 right there tells me to round that 8 up. If I were to round this, this would be about 61,495.8. All right? Now I'm going to switch colors here again, and I'm going to say, well, again, I want the smallest power of 10 that will be bigger than this number. In other words, I want a number that looks like that, right there. Okay? You put a 0.0 there, and that number is going to be bigger. That's going to be the smallest power of 10 that is bigger than this number. Because if this 1 was over here, all right, I'd take away a power of 10, and it would be smaller. It'd be 10,000, and that's definitely smaller than 61,000. So this is the one I want. Okay, and again, just use your rule over here. I want, now I don't count this 0 over here. This is past the decimal, right? I'm going to just cross this one right out. I want to count these zeros. 1, 2, 3, 4, 5. All right, so I want 10 to the 5th. That's that easy. All right. Now the next two examples are going to be a little different. They're going to be really small numbers, so we have to look at things just a little bit differently. All right, guys, the second two are a little different. Notice that these are very, very small numbers. You have the decimal right here, and you have the decimal here, and these are very, very, very small numbers. So again, we want to find the smallest power of 10 that will exceed that number. Okay, so let's just talk about very, very small powers of 10 for a minute, and then this should be pretty easy. Now, 10 to the 0 is still equal to 1, just like it was on the previous page, but 10 to the negative first is going to be equal to negative 1, or I'm sorry, 0.1. And here's why. Remember last week, or a couple sections ago, when we had a negative exponent, we said, well, the way you get rid of a negative exponent is you take that base and you move it to the denominator if it's in the numerator, and vice versa. All right, so if I do this, if I take that 10, take it down the denominator, that turns that into a positive 1. All right, so basically I have 1 over 10. Now if I go to my handy dandy calculator and I get rid of that mess and I take 1 divided by 10, I get 0.1, all right, which is what I have up here. Okay, what if I tried the same thing with 10 to the negative 2? Okay, I'd have 10 to the negative 2 over 1. I'd change it to 1 over 10 to the second, all right? That gets rid of my negative down there. And that 10 to the second is really 1 over 100. Well, you can see the answer I should get. Let's check it on the calculator. 1 divided by 100 equals 0.01, which is I have right there. Okay, so again, there's a little pattern there that you can see. And so I'll keep that list over there for now, and we're going to try to do these two. All right, guys, so what I want to do is, you notice I've added some things real quick here. I want to get a number that is bigger or exceeds this number. I want a power of 10. All right, so I wrote in the number that I want. Notice I've lined up my zeros, and I've stopped 1 short of that number, because if this was a 1 right there, that number would actually be smaller than that number. Okay, so this is the number I want. Now let's go back to my list and see a little pattern here. Notice when I had to the negative 1, I had, well, no zeros over here. I had 0 zeros. All right. When I had 10 to the negative 2, I had 1 0. Okay. When I had 10 to the negative 3, I had 2 zeros. So there's a little pattern there that you can see that's happening. When I have 10 to the negative 4, I have 3 zeros, etc. Okay. So I go back over here. What I want to happen is I want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. I want to have 10 zeros on that. So if I go with this pattern over here, if I want 10 zeros, I need 10 to the negative 11ths. And there's my answer. All right, go down to this one. Now that I see that pattern, all I have to do is count the number of zeros. All right, and actually, let's write the number in. This is what I want: 0, 0, 0. I'm just lining up zeros here, and I want the largest power of 10 that is bigger. So that means, oh, when I get to my last 0, I don't want to put my 1 right in line with that 8. I want my 1 to be there. All right. So, count number of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I want 15 zeros. That means, go over to my pattern over here and see what happens. I want 10 to the negative 16th power. And that's all it is. All right. So tomorrow we're going to ask you to do powers of 10 that exceed a certain number, and they could be really, really big numbers, or they could be really, really small numbers.